Institute for Integrated Hydro Environment Research, IIHR. My name is Ravi Kumar Mishra, and I'm a PhD student at the Indian Institute of Technology, Indian School of Mines, Dhanbad, India. And I'm honored to be your moderator for today's session. So before we dive into the topic, let me introduce IIHR. The Institute for Integrated Hydroenvironment Research is a non-profit research for development organization based in Nepal. We aim to stimulate the generation of knowledge and its application to solve critical problems in the field of water resources and environment. Our research activities follow a holistic and integrated approach to expand understanding of regional and global issues. We specialize in areas ranging from fluvial hydraulics to sustainable water resources development and management, through to eco-hydraulics, hydroinformatics, and water-induced disasters, including the effect of climate change. The webinar is made possible with the support of our associated partners, Department of Water Resources and Irrigation of Government of Nepal and Dynamic Solutions Private Limited. I would like to acknowledge the organizing committee, which includes Ishwar Joshi, Kamal Prasad Pandey, Khem Prasad Bhattrai, Naresh Sual, Pratyush Jha, and Rakesh Kumar Chaudhary from IIHR, and Ritesh Jaiswal from WSP India, and their hard work in making this event a reality. We are here to explore the essence of river dynamics and morphology in river management, principles and practices. This topic is vital as it delves into the core principles of river behavior and the practical applications in managing water resources effectively, issues that are increasingly relevant in today's environmental landscape. Before we begin, let me introduce our distinguished guests. Our keynote speaker, Dr. Sanjay Giri, is a senior specialist at Royal Haskoning, Netherlands, renowned for his expertise in river dynamics and morphology. Joining him are our esteemed panelists, Dr. Sarosh Karki, Senior Divisional Engineer at the Ministry of Water Supply, Irrigation and Energy, Kosi Province, Nepal, and Dr. Ganesh Khimire, Research Staff Scientist at Oak Ridge National Laboratory, USA. Their insights will undoubtedly enrich our discussions. I would also like to recognize our patron, Dr. Santosh Kaini, Deputy Director General at the Department of Water Resources and Irrigation, Government of Nepal, for his invaluable support. Let's commence the webinar with opening remarks by our distinguished patron, Dr. Santosh Kaini. Sir, please could you share your opening thoughts with us?
Thank you, sir. Good evening, namaste, and a very warm welcome to all of you. It is both an honor and a privilege to address this webinar focused on essence of river dynamics and morphology in river management, principles and practices. Rivers have always been the lifeblood of civilizations. They shape landscape, sustain ecosystem, and support human livelihoods. They are dynamic systems constantly changing in form, flow, and functions. River dynamics is an active and natural process that governs how rivers flow, erode, transport, sediment, and reshape their channels over time. Whereas river morphology captures static features like channel shape, meanders, and floodplain structures that result these dynamic processes. Understanding river, both dynamics and the morphology, is necessary for managing water resources, predicting flood risk, and preserving ecosystem. As urbanization, climate change, and human interventions increase, the need to understand the complex interplay of river dynamics and morphology is more critical now than ever before. One of the key pillars of effective river management is the development of safe and sustainable river infrastructures, including dams, reservoirs, and river structures, designed in harmony with the natural river processes and ecological integrity. This webinar is a timely opportunity for experts from across disciplines to come together and explore holistic, science-based, and nature-aligned strategies for managing our river more effectively. Today, in this webinar, we will investigate key topics such as river morphology, sediment dynamics, floodplain restoration, geomorphic modeling, infrastructure planning, and adaptive management practices. They are essential tools for safeguarding lives, livelihoods, and ecosystems in riverine regions. Thus, I encourage each of you to actively participate, share your knowledge, raise critical questions, and engage in meaningful dialogue. Let this platform be a collaboration and innovation where ideas flow as free as the rivers we strive to understand and protect. The Department of Water Resources and Irrigation is happy to collaborate with Institute for Integrated Hydro-Environmental Research, which is advancing water and environmental solutions through integrated research. We like to collaborate with research institutions like IIHR in coming programs to raise the awareness and advocate the river dynamics and morphology, which is a captivating sector to all of us who are working on the river management. I wish all good luck to the organizing team for the grand success of this webinar. Thank you.
Thank you, sir, for for setting the tone for the webinar with your insightful opening words. Now, it's my pleasure to introduce our keynote speaker, Dr. Sanjay Giri. Dr. Sanjay Giri is a leading expert in river dynamics and morphology with over 28 years of professional experience. He holds a PhD in river science from Hokkaido University, Japan, and an MSc in hydraulic engineering from St. Petersburg State Technical University in Russia, and a bachelor's in civil engineering from the same university. Currently, Dr. Giri serves as a senior specialist at Royal Haskoning, Netherlands, where he is also the team leader for the project implementation and support consultant for the climate resilience Brahmaputra flood and river erosion risk management project in Assam, India. Additionally, he is the technical director of River and Coastal Resilience Group at Haskoning, India, on secondment from Royal Haskoning, Netherlands. It's an honor to have such a distinguished expert with us. Sir, now I would like to request you to share your presentation, and the floor is yours.
Thank you. Thank you very much, Ravi Bhai, and thank you all, organizing committee, also Dr. Santosh ji, and it's an honor to be here to present our work about things what I have been doing. And once again, yeah, thank you for inviting me for this, and I hope that it will trigger some sort of discussions. And please feel free to contact and put your critical views, comments. I have many slides, but I try to make them very simple because I don't know the audience. Yeah, what will be the audience? But this is, I think, not the last time. So I will be, of course, I will be always happy to be here and present in any levels for practitioners, but also for academics. If you want to go into the deep details of the problem related to fluvial geomorphology. I did my PhD in this topic, and also been working in this field for almost 2 decades. And of course, science and practice. Yeah, so in general, fluvial geomorphology is a science, but also a very important aspect for the practice related to river management. It's very difficult, and that's why what we also see that it is might be like avoided to deal the problem. But as we see now, especially in our region, how dynamic river systems we have and how difficult to manage, it's very important that we should have some fundamental, knowledge about it, and also we should put efforts on all our projects to look at this problem and try to address it. So it would be kind of like a presentation where I very briefly go through some principles of sediment transport and river morphology. And I know some of you with already PhD degrees and all those, knowledge, it would be maybe very primitive, but maybe for some practitioners could be of some use. So it's just going through them, but will not too much, describe. I will not be very, descriptive with my slides. I will run through them, but there will be possibilities. Hope to also discuss this today and also in future. Yeah? And yes, some slides about knowledge-based tools and methods, which also I'm sure, and some applications of fundamental research, some selected fundamental research and real-world application, particularly the both research and applications where I myself was involved. I always like to talk about these aspects of river basin governance and management, particularly related to our country and in Nepal, as particularly related to like integrated and participatory river basin management aspects, and particularly the rationale and initial proposition for Nepal. But I'm not sure how much time I will have, so I'm afraid that if time will not be enough, I just have to run through it and maybe or do it next time. But I just wanted to touch this because I always like to do this because it's very important especially for Nepal. For India, it's a bit difficult because India is already matured federal state and independent, and these river systems are large. They have already system in place, even like all kind of tribunals to manage the problems related to interstate river basins. But for Nepal, which is a young federal state, this could be useful. So geomorphological processes, we are all aware of them, and we also know that how they are connected to all kind of river basin functions and ecosystem services. For example, and of course the processes could be in a catchment scale to the reach scale, right? So, and they are of course quite closely associated with, for example, agriculture and aquaculture, ecology and habitat, energy, and the quality, water and sediment, both groundwater. So when we talk about this, we also always associate that with safety and sustainability of water infrastructures that are important, especially in our region, in our countries, and catchment and floodplain wetland management, flood and erosion disaster management, sediment management. All these aspects, topics, disciplines, activities are very much associated and connected. And geomorphological processes, the considerations of geomorphological processes are very important while addressing all these aspects related to river basin management. So it's talking about geomorphological processes. So there are catchment to reach scale processes and extremes, which leads to generation, transport, and deposition of sediments. So for example, these processes are well known to you: glacial erosion, moraine breach, landslides, landslide dam outbursts, and sheet erosion, reel erosion, gully erosion, wind erosion, debris flows, and also river bank and land erosion. There are some rivers, I will show you, you produce a lot of sediment because of land erosion, river bank erosion, for example, like Brahmaputra or Koshi, and riverbed sedimentation and erosion itself. So there are diversity of geomorphological processes. If you go through, particularly in our region, in our countries, in our subcontinent, if you go through, you can find very different type of, features, geomorphological features like this. You see old fluvial deposits along the, even the when you were traveling, when I was traveling, like these pictures was made by mostly by myself. So you can see, depending on which region you are, very diverse geomorphological features, processes, and extremes. And of course, they have numerous impacts, like glow flow, debris flow, flash floods with high sediment load have numerous impacts, and we have been already suffering a lot from these impacts in our region. So I don't think I have to give you examples. You have been witnessing this almost every year. So these are all known and have quite an impact on our infrastructures, on settlements, even accompanied with their fatalities. So here are some pictures. So you see also not only in Nepal, but also like this left side picture is, I think, somewhere in Switzerland, I presume. And there is a dam you see up. It's in Nepal, in Saptakosi. And this is in India. This is in India, actually, all this abrasion caused by sediment transporting through the structures. So they can destroy the infrastructure, very critical infrastructures. These are energy infrastructure, road infrastructure, transport infrastructure, I mean. So here another example of like, you see the landslides that blocked the river. This is the Sunkosi landslides, we all know very well, and how it affected the hydropower upstream and downstream hydropower dams and infrastructures. So this is when I was there. The headworks was full of sediment. And this is another examples where I did also a project in Bangladesh. I was involved in a very similar project what I am doing now in Brahmaputra in India. So here you see, so standing bridge structure in the middle of the river. You see here like the erosion of almost 1.8 kilometer of land. If you compare these two images in just, I think, 2 floods. Yeah, so here you see this bridge was inland here, and it was eroded just in 1 or 2 floods. So you see the impacts, huge impacts of these geomorphological, fluvial geomorphological processes and streams. So now, from this introduction, let's go to basic theory and principles, but I am very concise, so I am not going to the deep, and some of you even know very well deeply these aspects. So, and also my focus now is reach scale sediment transport processes, not catchment scale. So when we look at the reach scale sediment transport processes, we classified them in mainly like 2 types: bed material load and wash load. So this is the classification based on the origin. So what is bed material load? The bed material load is the sediment that contributes to the morphological changes mostly, yeah. So, and that also we classify it based on the transport mechanism, that is bed load and suspended load. So in this figure, you can see that the bed load that transported mostly through the bed, while suspended load transported in water column, and they can interact with the bed, maybe in next slides, I will explain a bit about the interaction with this transport with the flow. And wash load is mainly like that go through whole the system. So they don't interact with the bed unless they are blocked by, for example, dams, or already in the coastal areas and estuaries when they meet the say sea. So when they have like the kind of backwater impact, they start to settle. So this is main the classification. So how we, I mean, in the river science, how we classified the bed materials, the materials that river carries. And yeah, water discharge, the bed material load is important for the morphological changes, as I already mentioned, because it contributes to the changes of river morphology in rivers and also around the structures. And bed load, yeah, the material that transport near the bed reacts faster to the changes in the flow, almost in the same, frequency as the flow velocity. But suspended sediment does not quickly react, so there is always a a time lag when they are when they react and when they like picked up and when they transport it and when they deposit in the river. So there is always a lag between the flow and the transport of suspended sediment. And wash load is even more extreme case. And as I mentioned, so wash load doesn't interact with the bed unless they are trapped in the reservoir or in delta areas, estuaries, and coastal areas, or where they have to settle in the bed. So for different problems, so there is, of course, how we consider what kind of material we have to consider depends on the problems and the problems that we have to address. So there are, of course, let me, okay, so now I quickly, move to like graded sediment transport. So we talk about uniform sediment, but in natural rivers, and especially if you look at our rivers upstream, in the mid-hill areas, or you can find strongly graded riverbeds. So these are also very important to understand. Yeah. So what kind of sediment gradation and features are in the rivers to handle them or to quantify the changes. So sediment sorting actually influences the sediment transport processes and also magnitude. So beside flow, also riverbed surface sorting governs the transport processes. And there are many, features and phenomena. So one of them is hiding exposure. I don't want to go into the details, but I just kind of am mentioning this term, hiding exposure, when between the sediment fractions. When there are mixed sediment, the fine sediment is hidden in between the coarse sediment, causing the reducing the transport rate of smaller size sediment, unlike if they are uniform, and or also making even exposure. So if larger particles are exposed and the finer particle below them trigger the higher transport of the coarser particles. So there are this kind of interactions. Sometimes we need to consider, we need to go to in a very deeper level to understand the transport and morphological changes processes. And there are also different, types of sediment sorting. Sometimes like the sediment bed could be well sorted, but poorly graded. So the gradation is not so high. If you say have a, deviation between the larger size and smaller size, there will not be that much. So it will something like almost quasi-uniform conditions. But that could also be the conditions when it's poorly sorted but highly graded. So the variation is pretty large, the variation of the size. But there are also situations when there is very very distinct bimodal type, like two types where two very distinctive types of segregation between the size. So this is just for giving you a kind of test about the graded sediment. I'm not going to do. I'm not going to talk more detail. That it can we might need the whole couple of hours to talk about all these nuances. And of course, in what we usually quantify is the sediment transport capacity. Yeah. So what amount of sediment passes through a certain certain part of the rivers and how they interact with the bed. So depending, and that depends on, of course, the gradients in the transport, and the flow. So when flow is slows down or fine, then they deposit or the sediment, they are picked up. So these processes, so the gradients in the sediment transport passing through some sections and going out through another sections. So depending on that, we get the changes in the bed. And there are several formulations. So probably many of you have been used that to quantify. Most of them are empirical. It's very difficult to physically replicate and calculate or compute sediment transport. But although there are very fundamental studies where you can also find studies, very fundamental studies that tries to look at even in the particle scale, the transport. So here what I want to show is that how these transport processes are connected to the certain morphological features. Yeah. So one of the features, just to explain, I mean, it's a bit probably an easier one, is transport in the bend. So if you go to the river system, you always see the inner side of the bend. So it's like there is a sedimentation, right, in the inner bend of the river. So what is this? Why this happens? Because it's affected by the flow in the bend. So there is a specific flow because of curvature. So the bed shear stress or flow, which is related to flow velocity, due to helical flow, takes the sediment from the outer bend to the inner bend. And of course, that's why the outer bend becomes deeper and inner bend is shallower. But at the same time, there is an equilibrium so that this process becomes an equilibrium. When there is a large slope, then because of the slope effect, so the gradient effect, the gravity pull, the sediment flows transported towards the outer bend. So you always, when you measure in the bend, you get this kind of bed, right? So in the inner bend, you get shallower depth, while outer bend deeper. So this process is as just one example, like how we understand this process, and you can even calculate this, and you can even simulate this. That makes these natural processes. It's sometimes important to also understand if you want to intervene the river system and what change will be there if we intervene our river system. So now moving to the river morphology. I have to follow the time. So river morphology is about river shape and riverbed composition. And so river shape mean like planform shape. So it's I will show in the next slides about the scales. So there's a planform shapes. So it's a large scale processes like meandering braiding, and there is a bed topography changes which is aggradation degradation. So which means that more meso and micro scale processes which is within the river, like for example the bed forms or migration of sandbars, pools, those processes. And of course, the riverbed composition. I already mentioned a bit about this in the graded sediment slides. So it's about sediment distribution and sediment sorting. So these are also meso-microscale processes. So the plant form means it's the lateral changes you see in many meandering or braiding rivers. So in the next slides, I will maybe add to this that so the rich scale features, if we talk about rich scale features and processes, so the large scale features, they are meandering and braiding. You see in our river system also, the river system that is, in the foothills or, I mean, in the lower part, after the foothills, you have a lot of braiding. And if you go lower, when the slope is milder, you see meandering rivers mostly, right? So, and there are mesoscale features, like I already showed, the one point bars in the bends, you see very clearly. You also see very clearly here, you see alternate bars, so these are like a physical process. So river actually is and this process is driven by a certain physical law, physical rule, which actually can be even replicate. And there are also steep pool morphology in steep rivers. In our hilly rivers, Himalayan rivers, you can see this in upstream. And there is also microscale processes. So there are ripples, dunes, river dunes, and anti-dunes. You see in low land rivers a lot. If you measure the river bathymetry in a very high resolution, like this one is in the Rhine branch, you can see here these features are dunes, and they have also impact. And so I will be maybe mentioning about this in my next slide. So here you see these dunes. They are quite organized mesoscale, microscale structures. This is replicated in a laboratory. I will show about this in my next slides. So these are features which is actually quite, distinctive and also follow certain physical rule. And of course, grain scale is it's about bed composition. So we are also familiar of in our rivers system, familiar about river systems where we have these processes prevalent. So that's why the morphological studies are very, very important and also very interesting, since our river systems are vulnerable to hydrometeorological and geomorphological extremes and hazard. So it is very important for detecting or understanding and quantifying natural and human-induced processes and dynamics, in the not only in the rich scale but also in the basin scales. So the dynamics this natural dynamics, what will be the changes if we do interventions? What will change? How those interventions will change the natural dynamics? And then how we are going to manage, and adapt those changes, and what will be the impacts of those changes in the interventions or measures that we erect. So it has, of course, the significance in the various sectors. I already mentioned in my first two slides, but here mostly related to river management, say for the flood and drought management. So how in the flood these changes impact. So for example, if I will not have time to much explain about it, but in the flood levels, for example, the micro scale bed level changes. So micro scale bed features like dunes and dunes might have an impact on flood levels. So they can create certain resistance, and also changes in conveyance of the river system because of the bank erosion or deposition also have an impact on the flood levels, flood and drought management. So it's not like just flowing in a concrete channel or clear water. And also for the land and floodplain management. So we have to understand the erosion accretion processes if we want to properly manage the land and floodplain of the river. And in general, river ecosystem, because sediment has an impact. Like for example, in a river ecosystem and habitats, and ecology. Yeah? So if sediment gradation has been changed, then it will have an impact on certain habitats, because certain habitats, we have some experts here, fish experts, they know what kind of habitats requires what kind of river conditions, where they can spawn, where they can live. And so these changes have an impact. It's not only just river management and erosion, sedimentation, or floodplain, but also the ecology and habitats. And of course, the water infrastructure. So I showed some examples, right? So they can have an enormous impacts. And you already can see it if you look at the projects in our country, in Nepal, India, all those hydropower projects and irrigation projects having large amount of, huge amount of problems related to sediment. So now a few slides about knowledge-based tools and methods. I think you know all this, but let me run through quickly. So of course, if we want to understand something or calculate something, yeah, we have to measure. We must have a, if we want to manage something, if we want to address something, we need to know the quantity. Yeah. So if what is not measured cannot be managed. Yeah. So it is a well-known proverb. So of course, there are many technology nowadays, because of the advancement in not only actually information technology, but also many equipment, uh, advanced equipments that can be utilized to measure these processes that I described in a very quick and precise, relatively precise manners, although there are always challenges. And that's why you also need the professional expertise, because all those measurements or computations or analysis requires a proper professional judgment. And because natural processes, of course, they follow certain physical rule, but at the same time, they are extremely uncertain as well, especially when you want to predict them, because this process depends on a large amount of parameters which cannot be quantified. So there is always some kind of assumptions. Even in the measurements, all these measurement instruments, they are, of course, not like straightforwardly always or directly measuring certain process phenomena, but sometimes it is just interpreted. It's just an interpretation. So that's why all this, outcomes, results requires a proper professional judgment, that we have to understand all the uncertainties and also the accuracy of these processes. And of course, we are now well equipped with many tools and knowledges, but still. So of course, the monitoring and measurements, so you already know those measurements and monitoring can be done in different areas, starting from the catchment and also along the river system. So depending on what we want to quantify, what process. So first, of course, it's all about understanding the processes and the interested and relevant areas. Sometimes it might have also, not that straightforward. It may be not always that straightforward. So certain processes, for example, in a river, where it has a say route, so and it may not always have in a catchment or or upstream of the rivers or downstream of the river, so it requires a lot of measurements and also judgment. So here are some examples of equipment you know very well. As now there are very advanced technologies to monitor the river system, flow, morphology, topography. So basically everything. So these are some examples where I myself was involved in some projects, and we were doing a lot of measurements in the field that can detect also like the not only morphology but even sub-bottom profiles. So what is below? Sometime when you do the morphological studies, you should also know not just at the bed but also below it to 20 meters, 30 meters, 50 meters, depending on what kind of rivers and what we really want to quantify. Yeah, so these are just about equipments we used also in the field cases and the laboratory cases. There are several projects you can find these materials, like in the Danube River. They have been doing a lot of studies, measurements, modeling, and well, one of the interesting tools is remote sensing. Yeah, so use remote sensing for the very helpful for geospatial analysis. So I think most of you are aware of this. And now there are, of course, a huge amount of data, images are available, and there are also not only images or data are available, but also the advanced processing tools and analysis tools are available now. Yeah, so you can build, like for example, Google Earth Engine, and they're also ready already. They're ready tools as well, where you can quantify certain changes based on the remote sensing data. So there are quite some data and possibility for monitoring and quantifying those processes that we have been talking about. So like we worked on this, one of the like satellite image processing techniques that called river morphology monitor. We were involved in developing the first also the methodology and then also the tools, and also automate it through an application so that the practitioners can use it. So these are actually ongoing works and knowledge and tools that most of you are already aware of them, I presume. And of course, the mathematical modeling. So this is also one very strong tool that you can use to enhance, like we use a lot to enhance our expert advice or judgment. It's not always easy, but with an expert backup, you can utilize these tools to enhance your advisory, the quality of your advice, and also the understanding processes, and also sometimes predicting. And of course, there is a purpose for why we need modeling. So for fundamental research or for applied research or engineering or consultancy. So then there could be even different types of tools and models, software, and then you have to be careful how you then consider and use them and what it produces. Yeah. So what the each model produces, so, and what is behind it. So based on the purpose, there are certain requirements. So I'm not going to read out. You can read it afterwards. But based on that, so some of you are already now involved in the fundamental research. So you want to maybe capture very local and complex processes, which has a very small spatial and temporal scales. Then you need a certain types of high order, models that resolve the very high order schemes. High order in a higher order level, the schemes that solve your problem in a higher order levels, and it captures non-linearity of the processes. But then you cannot use it in a practice in a large river system. And there's also applied research. So research means, of course, you can have an innovative methodologies. You can have parameterization, and then you can again have a judgment. And these models can be used for checking your hypothesis, triggering discussions, or even some short-term predictions. And for engineering and consultancy, also you can do very quietly, very rapidly, for some rapid analysis. So you do in a very simplified manners. the modeling, but then you have to understand like what could be the, uncertainties and inaccuracies. All those models have uncertainties and inaccuracies, of course, but in the different levels. So, and of course, when it comes to morphological modeling, the morphology is always at the end of the modeling chain. So first you replicate the flow, so hydrodynamics, and then you connect that with the sediment transport. I already mentioned about it. And then you see how the sediment transport interacts with the bed, and the morphology has been changed. Yeah, so your river bed is changing. So these are the processes that also actually you can replicate in the natural processes that you can replicate in the computation models. As I already mentioned, that those features or processes follow certain physical rules, but we don't have all the relations or mathematical relations, or also it cannot be solved directly. So we have to do parameterization or simplifications, and that's why there are certain uncertainties and inaccuracies. And of course, there are the special dimension of the models. So you can have like one-dimensional, two-dimensional, or three-dimensional. I'm not going to explain about this in detail. I'm afraid that I may not manage in time. But yeah, there are, so this is also the choice that you make depending on the problems. So, and this also depends on like the purpose, as I mentioned in my previous slides. So for research, for very small scales, maybe you also need the spatial dimension is more higher. So you want to have a more, for example, processes three-dimensional, so that you capture all the, complexity. For example, the flow around structures are always very complex, three-dimensional. While if you have to large, wide river, shallow, the process may be just two-dimensional, and that's good enough. So it's all depends on the process and the problems that you are going to address. So, and there are also laboratory and also physical experiments. So this is an example when I was doing my PhD and postdoc in Japan. There is, a divergent channel in a real river, and that divergent channel was made a kind of also an experimental channel. So as I showed you briefly before, here for example, this my postdoc topic was about dunes, river dunes. So you see, so the dunes are replicated in this channel, which is pretty wide. It's almost like a natural stream, and these all materials are natural materials from the river, and it's controlled by, of course, certain hydraulic gates. It's a divergent channel. Actually, it's a flood divergent channel in the Tokachi River. So, like you have also indeed also inside the laboratory or physically here you see some measurements of these dunes, like how this is the bed level, and then the velocity was also measured. So we use that to also verify our numerical models. Of course, there are also empirical, analytical, and AI tools. Like this is one example of erosion prediction empirical models that is used actually also in our practice for example, in Brahmaputra in Bangladesh. So now we are also considering this for the Brahmaputra in Assam, but these are conceptual, empirical, and but also the neural network models based on the huge amount of like satellite images. Of course, now you all know this word about AI or machine learning. So there are, of course, hybrid approach. There could be that the AI can be combined with the process-based. So process-based models can create data for the AI model, since there is not always, it's not always possible to collect the data physically for all conditions. So you can also utilize the process-based models to create data and then maybe come up with some simpler relationships or models that can be utilized for the practical purpose. So let me give you some examples. How much time I have? I'm not sure actually. Let me go quickly actually. So here are some examples of research and real world applications. So let me go quickly, okay? So not to spin. So as I said, micro-scale morphology, river bed forms. And so river bed forms has, of course, an impact on the flood level and also the bed level. So like because of dunes, so bed becomes shallower, depth becomes lower. So it's very important, for example, for the Netherlands, for the water transport in a low flow period. These dunes, they disturb for having the proper depth, navigable depth. So they have to dredge them. So that's why they also try to analyze the evolution and development of these dunes, because you dredge them, but they again appear. Then yes, and it has another impact. It is like the flood levels, because it has a resistance. It creates a resistance to the flow, and then your water level goes up because of the resistance created by the dunes. Yeah. So, and it has also actually impact on river ecology, because it actually sediment. It captures the contaminants. So it captures the contaminants and substances, and then transport them together. Yeah. So, and also it changes, impacts the habitat suitability, as I already mentioned briefly in one of my previous slides. So we did the research. This was my postdoc research, and we tried to develop some fundamental, models, CFD models, to understand the physical processes, how these dunes impact on the flow field, on the flood levels, and also how the evolution of the dunes, how the flow, on the other hand, impacts on the evolution of the dunes, under which conditions. So those kind of studies you can find in our publications. And they're also in my university. So they used to do some fundamental research on river meandering, simulating physically using the models, numerical models. Of course, it's very difficult to implement it in the practice in a large scale, but it is quite fascinating that you can see that the processes can be, even in a small scale, can be replicated by using a mathematical model. So there's a lot of complexity, but so a lot of things can be done. And sometimes knowing the certain fundamental processes already enough to understand and address certain even large scale problems. So there are many type of research. Some of you yourself are engaged, but I don't want to give the details here. And now I just go very quickly some projects. These are projects that I'm involved now in Assam. I think I had to remove this. So this is the project called Climate Resilience Brahmaputra Integrated Flood and Riverbank Erosion Management Project. This project has all kind of components. It's structural components, and there's also implementation of riverbank protections. It has a non-structural components like knowledge development and development of flood forecasting system, development of erosion prediction models and systems, as I briefly mentioned, and also all kind of other aspects like adaptive management and regulatory strategies. Also improving guidelines for river management and also river training. So capacity building. So all the soft structures. But structural part is mainly the riverbank protection stabilization measures, mainly using geobags and porcupines. So river will be, the project will last 5 more years. It's ADB funded, 250 million USD project for phase 1. And in this project, we are also responsible to prepare the all kind of planning, design, and feasibility, as well as preparing the documents, loan documents for the phase 2. So this is about. I'm not going to details in this project because we started 1 year ago, and many things maybe cannot be even shared for now. So I'll show some other projects like in Koshi. So I have several students. Most of them were from Nepal. They did several works on Koshi River. Here is one was studied. So you remember this Koshi Bridge problem. So several students actually worked on this problem with me, and one of them did also using satellite images. So how Koshi River had changed in the last 40-50 years, how it became narrow and basically created this problem and one of the reason was also of the bridge was also because of the changes, and mainly the changes as an effect of the barrage. So the river become narrow and then concentrated along the eastern embankment, and somehow managed to bridge an embankment even in a moderate flow conditions. So these are the studies that are also the tools that gives us ideas and about the processes, and also the reason for certain failures, and also the help us to how to then manage these processes and extremes. So here also, like, this was a numerical model done in Hokkaido University of the bridge process itself. So you can see here like the bridge. So the flow and sediment transport due to this bridge, we try to quantify it using the mathematical model. So this just shows what a mathematical model can also do. Of course, we have to be very, very careful when we interpret these results, because these results are very sensitive to several parameters that we use in the models. That's why interpretation require a proper expert judgment. And this is another project in Bangladesh I mentioned briefly in Jamuna River. It's mainly about the Jamuna River flood and erosion management. So it's also had all structural and non-structural components. So we used a lot of monitoring, field data, sediment monitoring, a lot of measurements you can find that gives you indeed a lot of information and knowledge about the system and processes, and then makes it easier all those interventions, and saves money, because then we can try to optimize the work. Like this is the measurements, bathymetry measurements. So like I've been using since 2011 data till now, till 2023, how the river is changing, so it really gives a very clear impression about the changes in the river system. And somehow it also actually allows us to predict in a short term, predict what could be if we intervene, and also how to intervene, how to make our interventions and measures optimal and effective, so they don't fail or they remain sustainable. So these are all measurements. Like in the bends, I showed you one example in the beginning of 1.5 kilometers of 1.8 kilometers of erosion and the bend. So this is that bend. So we measure this bend constantly, how the bed changes along this bend. So it gives an idea about like how it will be evolved in future and how we can manage this problem. And so there are a lot of quantifications on the changes. I don't want to give you details. Like here is one example, the changes in bed level between like September and December. So which means that the impact of the flood, just one flood. So how much changes could be in the Brahmaputra in like Bangladesh in this could be just in one flood. There are million cubic meter of sediment have been deposited just in one flood. So these are like, and there are of course as I said, the image analysis techniques that gives you the changes between two period. Some of you know well, and you can see how you can see the processes, you can see the features, then you can design and implement the interventions, and also predict the effectiveness at some to to a good extent, rather than just doing things blindly. So there are many, we have publications, you can look at them. I put it in the slides so you can take, I presume that the slides will be shared with you all. And then if you have any questions, so we of course use these all data to verify the models and then utilize the model for implementing the measures. So these are just examples of this Brahmaputra project. So like this is like dredging dumping. We wanted to close a channel by dredging material from somewhere and dumping another place. So you see here just animations. This is a river, that the channel that we wanted to close. So here you see the placing of the sediment. So red means higher topography. So we are putting sediment from two sides and then see how it will impact the flow. So these are actually simulated by the numerical model first before implementation of this. So we are trying to quantify how much sediment will be needed, and what will be the process of erosion during this filling, because you cannot like close the whole river. You have to do it in a low flow where water is there. So these things like can be somehow, not maybe fully accurately, but somehow you can replicate, and then that will be helpful. Same with another river, Kopili, we just discussed today. We had a project there, and we tried to look at the flow and sediment and morphological processes along the river, and then we gave the recommendation of how the flood and erosion management plan and strategy should be built based on these processes and changes. So what are the nuances along these rivers? And there are several problems, and of course there is a flood and erosion. There was a huge flood in 2022, record historical flood, and a lot of erosion, bank erosion problems. So we try to understand first the processes related to sediment transport and morphological changes, and then give an advice on how the river should be managed. Yeah, so like we sometimes just look at the images, and combine with our field trips, and then give our expert judgment. That can be quite useful. And of course, sometimes we also use satellite imagery, which can quantify the changes in the river. You see how the meandering river is changing. This is also the part of Kopili River, which is changing, and that can be quantified using several techniques, and that is useful. And same with the modeling. So these are like different projects. Here another project in India. Let me pass it. I think I don't have time. Here is another project in Japan that also included the reservoirs. So the impact of the reservoirs along the Tendu rivers. So we try to look at the first also, and it also included actually the basin scale sediment generation, so catchment erosion. So we try to quantify from where the sediment is coming to the river and to the dam. So like soil erosion, a certain part of the sediment is coming from the catchment erosion, some are stream erosion from the river system itself, and then how they impact the reservoirs. So it was quite, and then also the ecology actually. So the ecology and habitats, because in the Tendu River habitat, Ayu fish is very important, so we try to see how the impact, how the dams, they change the sediment transport and also the gradation. And so river morphology and gradation, because gradation was very important for spawning habitat. So we combine those flow and sediment model with the ecological models, and try to look at the favorable and unfavorable conditions for habitats and how to manage that. Yes, so that's it. I think my time is gone, I think, right? So maybe I will skip this part, not sure. So I wanted a little bit to talk about river management,
So you
so we
can definitely like take some more time if you want,
okay,
like
5 minutes. I will try just quickly.
yeah, just
Of course, these things, what I mentioned was more about morphology and more technical aspects. But of course, when we talk about river management, so it has various functions. A river has various functions depending on the region, country, areas, and might have a multiple use, and it could be multidisciplinary as well. So this is the kind. So integrated means we have to consider all those functions and utilizations and also the disciplines. The another aspect is also of course the participatory approach, right? So it's about the basin governance. So there are of course many federal, regional, and local state authorities and water users. There are also technical support units, knowledge institutes, think tanks. So this is the governance part. So and that's why it should be integrated and participatory. It should consider both the aspects. So what I tried we presented that in the past as well, particularly for the Nepal, to have an strong, integrated and participatory river basin authority. So which can deal with both the aspects. So to integrate the multi-purpose, multiple use, and multiple, uh, functions of our river basins, and at the same time also the participatory governance. So and this will be, and the federal system actually has given us a chance for that, but unfortunately we are still far from this, and we will already see the problems in future between the provinces, the states. But this was the kind of propositions that we presented in the past several times. I think, yeah, I can have a separate lecture about this, but I just put it because maybe it could be of interest for you, for some of you. So I put it in the slide. But and in Nepal, it is of course it's possible. And so we have already quite some agencies, departments, and that can be so institutionalized within the river basin authorities. We already have any technical support departments as well. So we have institutions and not different authorities, but it requires, of course, maybe a different form of institutional structure. Yeah? If we want to establish a strong river basin authority, and also a willpower of our decision makers, policy makers. Yes, I think I would like to stop here. I better try to give some time for a discussion. I hope that is not too much, how to say, exhausting, but I just try to indeed to give some information, and if you need to know more about certain aspects or components that I presented, I will always be ready to answer you today, but also in the coming days, in future, and also make presentations more specifically on certain topics, components, aspects. Thank you for your patience listening me. I hope that it was somehow clear. Thanks, Raviji, for how much time I
Thank you
spent.
so. Yeah,
A lot here.
it was very interesting. Thank you, sir, for that enlightening presentation. I truly appreciated the comprehensive coverage of both theoretical foundations of sediment dynamics and river morphology, paired with the practical examples from the field that you provided. The overview of the measurement tools, remote sensing applications, and mathematical modeling techniques was particularly very enlightening and added really great value to the session. Also,
Thanks.
the examples from the fundamental research and the field applications in both India and Nepal. I hope that is of interest to all of our viewers, and they will really appreciate it, I believe. Also, I request all the participants to submit your questions via the chat for the Q&A session that will happen later. Right. So we'll now move on to our panel discussion. So now let's move on to the panel discussion session, and allow me to briefly introduce our esteemed panelists. Right. So first we have Dr. Sarosh Karki with us. Dr. Sarosh Karki is a water resources and irrigation engineer with more than 10 years of professional experience in Nepal's water sector. He completed his PhD in fluvial hydraulics at Kyoto University, Japan in 2019. Over the years, he has authored numerous research papers and articles featured in both national and international journals and media. Currently, he serves as Senior Divisional Engineer at the Ministry of Water Supply, Irrigation, and Energy in Kosi Province, Nepal, where he leads the development and implementation of water resources and irrigation policies and programs at local and regional levels. Sir, we are really delighted to have you here today. Now, I'd like to give a brief description of our another panelist, that is Dr. Ganesh Khimire. Dr. Ganesh Ghimire is a research staff scientist in the Water Resources Science and Engineering Group of the Environmental Science Division at Oak Ridge National Laboratory, ORNL, in the United States. His research at ORNL spans a broad range of water resources, including large-scale hydrological modeling, flood simulation, stream flow forecasting, high-performance computing, extreme event analysis, uncertainty assessment, hydroclimate impact assessment, water energy nexus, and machine learning and deep learning applications in surface hydrology. His PhD dissertation on streamflow predictability across space and time scales was awarded the prestigious Ballard and Seesaw PhD dissertation fellowship by the University of Iowa in 2020. He is also actively involved in water resources research in the central Himalayan region through Water Research Group Nepal, and has frequently reviewed more than 10 high impact scientific and engineering journals. Sir, thank you for joining us today. I would like to now request the panelists to please unmute their mics if they can.
Yes,
Can I
thank you. Okay. Yes, yes. Ganesh, you can proceed.
Oh, thank you.
Yeah.
Thank you, Raviji, and then thank you, entire IHR team for inviting me to be on the panel, and hear this impressive talk by Dr. Sanjay Giri, who has done an impressive body of work, especially in the field of river dynamics, geomorphology, and then their implications for river management. It was really a great talk today, especially given that I haven't done sediment transport modeling work for a while now, and understandably so, given the how complex sediment transport itself is, as Dr. Giri highlighted upfront. It was quite insightful in a way, and then it was a bit refreshing for me at this, given some background to sediment transport modeling back in my master's days, when I did my master's thesis in sediment transport modeling. Then I had to switch, understandably so. In today's presentation, it was quite impressive the way Dr. Giri covered the whole spectrum of river sediment transport, its role in river
dynamics and shaping the morphology, and especially in the context of the river management, which he highlighted at the very end. And I think that's the way we want to go moving forward, especially in the context of changing climate and the intensifying hydrologic extremes, among others. Yeah, it was a broad overview of things to start off with the relevant details, and then sediment transfer theory, mechanics, among others. So that was, yeah, very, very refreshing indeed. And then, yeah, he provided with some real world examples, applications, projects, modeling works, among others. So it was really great to see that. I think, yeah, in the interest of time, I think I'll keep it at that, and then probably after Dr. Karki, we can have some follow-up questions if we have some time for Dr. Giri. Again, thank you so much for that interesting talk, and then yeah, thank you, IHR team.
Thank you so much, sir. So I would like to come to Dr. Sarosh Karki. Sir, so from the talk, we understood how important river morphology is, especially when we come to river management, right? And how the critical role it plays for understanding the behavior of river, as well as for any kind of engineering planning that is around around the rivers, right? So what are your perspectives on this, or what are your insights on this in context of Nepal, and especially Kosi, because Kosi is a very important river system.
Yeah, okay. Yes. Thank you, Raviji. And first, I would like to thank IHR for having us in this very important and practical topics. So first, also, I would like to thank Mr. Sanjay sir for his compelling and very articulate presentation. It's always a pleasure to listen to his experiences on river morphodynamics and practical applications that spans from the Himalayas to the coastal areas. You have vast experiences in that field. From my point of view today, I would like to share an overview of how river dynamics and what role it plays for the sustainable river management in the context of Nepal. Briefly, not at the micro level, but at the country level. Basically, river morphology and morphodynamics, as we understand, is a very classical science. And it's not a very glamorous or fancy data-driven type or software type of topics that usually popular these days. But recently, due to the advancement in the remote sensing technology and machine learnings and like the drones technology and the other processing tools, it is slowly getting attention and popularity among the students and among the professionals also. So, but in the context of Nepal, as we all know, that it has a unique geography that ranges from the highest mountain in the world to the low-lying plain in the Tarai region. Yet it is very unfortunate that the importance that the river morphology should be given has not garnered that attention from the policy point of view or from the research point of view. So in that context, currently in the context of Nepal, river morphology is directly linked to the areas like the irrigation development or the hydropower development or the construction of the river training projects and bridge something. So massive investment is made in these areas every year. So and the river morphology, the sustainability of all these projects hinges on the the balance of the river morphology. So this field needs a lot of attention, in my opinion. And currently talking about the downsides of river morphology in the context of Nepal, I think the first is that the importance is very limited. from the government sector. And the second is we don't have the data monitoring and data high resolution data of river cross sections or river sediment. So due to that, it has hampered the execution of research works. So students they hesitate to conduct research in the field of river morphology because they say that we don't have data, and we it also needs extensive computational efficiency. And in the context of Nepal, that is also very limited in the universities and in the private sector also. The computational efficiency is not that much as it is required to simulate large scale large river systems, hydraulics and sediment transport, I mean, characteristics. But having said all this, we know there is challenge. But until we take a decisive step towards addressing this problem, then the problem will continue to persist. So we must take some steps. We must take some steps, even there is challenge, even there is the data limitations, but we should take initiative so that one day we will reach to a point where we can say, oh, okay, the river morphology has also produced some kind of useful contributions to understand the river systems of Nepal, and that will directly help the development of water resources project. Like the government has planned several water resources projects, and the success of these projects hinges on our understanding of the river morphology and the river systems. So this should be prioritized. That is one of my opinion. And talking about some positive aspects, there are some aspects to be optimistic about in the recent times. Like the river morphology is slowly getting attention, particularly in the aftermath of the disasters like the Kosi flood disasters in 2008, and then the Melamchi disaster a few years back, and then the recent flood in the Kathmandu and the central Nepal. So, and there is also public awareness and public discourse. The media is also writing on these issues that, okay, the rivers should be managed. And the most important thing is the application of remote sensing is growing in the context of Nepal due to the availability of satellite imagery and due to the availability of Google Earth Engine and similar processing tools. So I think that will play a crucial role in the coming days in advancing our understanding of river morphology and river morphodynamics. So, and having said all this, what we can take forward is that we need a collaborative initiative that involves all the key stakeholders, such as the universities and the Department of Water Resources and Irrigation, Water and Energy Commission Secretariat, that to elevate the river morphology as a critical area of study, and that such collaboration can drive progress in morphological research and lead to the development of some standardized guidelines and for morphological analysis. And additionally, what I want to add is that there is a pressing need to produce or to cultivate a multidisciplinary pool of experts and enthusiasts across universities, across government institutions, and other relevant institutions. These professionals, what they will do is, this professional spanning field such as water resources, geomorphology, policy, will play a vital role in advancing the integrated and science-based river management in Nepal. So I think the coming days are, we can be very optimistic in the future that the river morphology will garner the attention that it deserves, particularly in the context of Nepal, where we have very challenging terrain and very variety of rivers and landscapes. Thank you.
Thank you so much, sir. It was for your insightful overview of it. And so I would like to move back to Ganesh, sir. Sir, so having worked in the International Research Institute, right, in the US, and also having lived over there for a long period of time, what do you think engineers, especially practitioners and researchers in this part of the world, especially in the Himalayan basin, right? Whether it's Nepal, India, Bangladesh. So in this part of the world, what engineers and researchers can learn, or what they are not doing what engineers over there are doing right. So do you have any?
Oh, yeah. Thank you, Ravi, for that question. So, yeah, at least there are some learning lessons. At least, like I pointed out earlier, and then Dr. Giri highlighted at the very end, this basins integrated basin scale approach, what they call here typically as watershed approach, or sometimes participatory watershed approach, kind of. Way is something we can follow back there as well, because it's not a rich scale process only that drives a lot of our river management strategies or policies going forward. It has to be the integrated approach. So be it any uh, nature-based solutions, best management practices, or other strategies that you plan, especially under changing climate. It has to be at the basin scale, because the a lot of influx of the sediment is through upstream, especially in our context, given the lot of, for example, road infrastructure development or sand mining, for example, another key issue that we see back there, as has to do with the sediment, has to do with the catchment scale processes. So that's definitely one thing that we should learn, and then more so because ours is a young, fragile mountain. So we a lot of times, yeah, we come across this uh, erosion issues from upstreams, be it the channel bank erosions, or landslides, or some of the examples that Dr. Garki also highlighted, be it Melamchi, or so. That definitely is one of the key lessons. And then the other is the stakeholder engagement piece, because it is going forward, it has to be this participatory approach, where you constantly engage the stakeholders, where you're proposing the solutions for, and then loop that feedback in your decision-making process, be it your structural or non-structural solutions that Dr. Giri was highlighting in his presentation earlier as well. So I think those are a few examples that could really help, or can be applicable in our context too.
Yeah. Thank you, sir. And thank you for bringing sand mining, because sand mining happens to be my research domain as well. So I have a bit of question for Dr. Giri. So, like sand mining, as we know, is very much prevalent in this part of the world, right? Especially in Brahmaputra Basin, or even in Kosi, or in Nepal's other basins as well, right? So it is whether sand mining, gravel mining, any kind of aggregate mining, it is very common, and especially in the era of rapid urbanization and the economic development that is happening, right? So how can we, like, because another thing is there is not only sand mining, but also we can say like somewhat of illegal sand mining, right? Where we do not have the data, appropriate data, like what is being mined from the rivers. And also in this part of the world, there is lack of like all the field equipments you showed. Like over here, engineers and consultants, they lack these kind of equipments, right? So how can we, overcome these shortcomings, right? And how can we like monitor the river and river changes more accurately, and how can we drive our research in that direction so that we can overcome these shortcomings and still produce like accurate result, and increase the awareness about these problems.
Yes, thank you. Thank you for your questions, and also thank you for the opinion from Ganeshji and Dr. Karki. Yeah, your question is very valid. So when I talk about river interventions, right? Sand mining is one of the river interventions. I always say, our rivers in our subcontinents not only rich with waters, they are also rich with sediments. Well, you need sediments, not only in our country, but also in other countries in Europe, like here also they mine. Otherwise, from where you get construction materials? Yeah, so you cannot build in somewhere like, so you have to use them, and it's a resource, in fact. And I see enormous resource. Sediment is, enormous resource in our subcontinent. But the point is how you use it, because if you even if you extract water randomly, it has also a lot of impacts. Although you need water to drink, and that comes from the nature. So it's all about like how you utilize these resources. First, of course, we have to understand that these are resources actually, and you can even use them, for the like country's prosperity, because these are really valuable resources. But at the same time, when you utilize them, which means that you are intervening your system, right? Your catchment, your river system, then you have to assess the impact. That is a normal process. Also, you can see in the developed countries how they, study before they, intervene. Or so that's why morphology. I mean, also hydraulics, morphology, all these processes. When we understand, then we understand the importance of those processes, and then also actually we can optimize also actually how to utilize like those resources. So when you mine, like I told you about Kopili, right? So there are branches of Brahmaputra which are stop at Brahmaputra, and there are branches that are sediment overloading. All the sediment coming from catchment simply deposits in this river. They cannot go like into Brahmaputra, or there are like Kopili is one of them. So the river is overloaded, which means that bed is going up, and it creates actually more flood impacts. So just building embankments along river will not solve that problem. So there is the overloading of sediment also in our rivers, which means that you maybe have to manage those sediments. But then you have to indeed manage it in a proper way. So you have to remove the sediment from the right place and not where you want and where it is easy. So you go by road, by truck in the bridge, and then just go below a bridge and near the bridge pier, you are mining sediment, then that will not work. Correct. So it's not like where it is easy to mine, then you go and then mine. No, then maybe, yeah, indeed you have an approach. So, and scientific approach, yeah, where you study, then you allocate, and then you also maybe even develop the infrastructure for mining and processing. So you make it all systematic way, and then everything is fine. If you do all in systematic way, in an illegal way, then nothing would work. And these resources, they are a huge amount of money, and you just need to spend 1-2% of that money for studies, or developing a kind of knowledge. Like it starts with in the context of Nepal and India. I say it starts with even in the universities. Maybe you have to develop more in depth, like departments even, and curriculum. So all the students to work with me were very satisfied, very happy with what they learned, and they found it fascinating topic. Yeah, and like Dr. Saruskarki rightly mentioned, now because of the technology, it's really become very interesting and fascinating also and actually data, not always actually, morphology is the topic where you can do a lot without data. Now just by remote sensing and even doing some scenario analysis and hypothetical studies, it will still be scientifically sound. And also like Dr. Sals said, and then you can also build like how you indeed measure your system. So it's not about only mining, but also other interventions, river training, dam constructions. If you go along all our hydropower now it's all run of the river, they say, but you can find in most of them we have problems. Yeah, and if you look at if you do the performance evaluations of those projects, you will find that, they are. So what is required is indeed a system, regulations that would be followed properly. So mining itself is not a bad thing. Yeah. So sometimes we think, oh, mining comes to your head, it's bad. Yeah, it's not. It can be even useful. It can be a part of the river management component. So it's not a bad thing. But when you do randomly and then we see the impact, bad impact, then it becomes like in our brain, oh, it's bad. Mining, you hear this word, already you think like it's bad word, right? So,
Yeah.
But it's not. Like in Kopili, I suggest like mining is important. But in Kopili, I saw they do mining, but they do randomly and it has negative impact. If you do it randomly, although river is overloaded with sediments, but when you mine not from a proper place, then you will impact that place. And that requires data, that requires studies, impact studies, analysis, and you have to invest on that. Yeah, you have to put some time and effort, but not just go in the river, mine and then make money. So it's like that. So here in the developed countries, like I got a job because of that, because morphological studies are given a lot in practice. And that was the reason I got a job in the Netherlands with my specialty. Although I think my specialty is much more needed in Nepal, India. Yeah, so because there are so much problems. I mean, you can really do very interesting things also. And here I think the problem is much less. But still, because by doing that, they save money. They save money also. They actually, even those people who are mining can earn more if they invest on studies. So if you can convince that, if we can convince that them also that you will earn more money and your work will be more efficient and more effective if you invest in studies, assessment, involve people, experts who do properly the work, then it is actually good for them as well. So that's also, I think, what we have to do probably as a people, that to bit awareness, create awareness about the importance of and that will be a benefit for them. So this is just answer to maybe not only your questions, but some.
Yeah, thank you, sir.
Yeah.
Thank you. Now, thank you, Sanjay sir, Ganesh sir, and Saroj sir for all of your insights. Now we'll open the floor for the questions by the participants as well. So
I'm looking at the chat now.
Yes. So we can.
So this is how we can predict. Yeah. Well, geospatial technology. Well, as I said, you can quantify a lot the changes, but you cannot predict future, of course, just by geospatial technology. But what is possible is that by quantifying the processes, I mean, by understanding, by using these tools and understanding the changes and processes, you can say with a certain knowledge. So if you have certain theoretical knowledge, you can use those data of the previous changes to somehow, predict some short term. Okay, maybe future on 1 year, next flood, this could be, changes could be like this. So there are actually there are certain tools and where this kind of approach is being used as well. And the another question is, well, yes, so you can use, of course, numerical models for sediment routing, governing equations, performing sediment routing. So, okay, it's quite fundamental questions. Yeah, well, governing equations are what, when you solve, for example, a morphological problem, then you have, first you have to deal with the flow balance. So you have a mass balance, momentum balance. So the main equation is the Navier-Stokes equation, right? So and then you simplify that to Sandvenon or 1D, 2D, 3D, right? So and those equations are combined with the sediment balance. So you have also sediment balance equations. So what is the morphological changes? It's about the gradients in the sediment. So you get gradients in your sediment transport, you get your bed changes. So to solve this problem, you have indeed mass and momentum balance of flow, and then mass balance, Exner equations for sediment on morphology. Anyway, this can be the whole lecture. If you are interested, of course, I mean, you can also read some fundamental books. Software, we use different types of software. There are like, I myself used a lot in Delphi because I worked at Deltares for 16 years. At Deltares, developed software, various software, and their morphological software is quite strong. It can actually do a lot, especially Delphi morphology. But we are also familiar with other software. I mean, the basic principles are more or less same in all softwares. So is there any role of river morphology on influencing backwater effect at confluence of two rivers? Seem to backwater confluence Nakhu and Bagmati river. Yes, correct. It's a backwater, definitely. You have like in Nakhu, I understand, but that is the effect is not only because of the backwater from the Bagmati. They channelized heavily in Nakhu and they encroached all the area. If you look at the Nakhu River 2003, how it looked like, and you look now, and you could already say that they just invited this flood. Yeah, so when they encroached the river, they built even the hospital to encroach the part of the river. They built the whole colony there, Awas colony, yeah, and in near the confluence. So when they build this infrastructure, you know, they had to consider all those things, including confluence. It is indeed at the confluence with the Bagmati. So Bagmati has definitely an impact, backwater impact, yeah. And they channelize the river because the river is morphologically active. It was wide, so they channelize completely, and they not only channelize river, they completely change the feature of the river with this all masonry wall. And so it was heavily encroached. And anyone could say that this kind of flood, you know, could happen. And the same could happen also in Bagmati. We have encroached the Bagmati so much that if you see Kathmandu is under the flood, you know, someday it will not be a surprise. So thanks for everything. Would you? Yeah, tools, guidelines for planning, design, sediment dredging work. Yeah, for dredging, again, the same like mining I discussed already. So dredging, I take like mining. There are, of course, ways to consider, and indeed, to consider the impact, you can study indeed the impact of dredging works. That's what we have been discussing. Groundbreaking. Okay, share your opinion on what more groundbreaking studies can be done in future in river dynamics. Well, we have to start. So we have to start to develop river morphological disciplines in our, starting from our academic institutions, because we must have experts. We have so much river morphological phenomena that in Nepal and India, there must be experts should be there, and not from outside like we are coming and or some, because a problem is there and you can see it every day, and people, even engineers, they are very experienced about rivers and but you can maybe connect them with the science as well. So make a discipline, maybe focus on dedicate, like here in the Netherlands, it's quite dedicated topic in the universities as well. So there are many morphologists in this country, although morphological problems in the rivers are very little, but they have, because they, even with the problem they have, they still want to address it to make their all river interventions work effective and financially and technically also, optimal. So in Nepal, actually should all start with the awareness, and also even starting from improving the academic curriculum, even dedicated faculties and even research institutions that maybe will be looking more also on morphology, not only water resource management or all kind of blah, 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 but also a bit science, river science. Yeah? River science, we are very talented people you see here also in this forum, working there, doing their PhDs in different countries. So now actually there is quite some already human resources as well. Dr. Saros Karki working in Nepal. He is already a very good expert, morphological expert, but I don't think he hardly finds probably time to do any morphological study. Am I right, Dr. Saros? You hardly do
Yes,
any
sir.
morphological study, I guess.
Yeah, you're absolutely right.
So all your knowledge is kind of gone, right? So or going or
Yeah.
fading. That's
Yeah,
pity.
sometimes I make time to guide some students. I encourage them
Yeah,
to
exactly.
do
So you are trying indeed. I see some individuals there or my previous students trying to do something working, but youth people should get some attention and also some resources and possibilities within like irrigation department or set, so you can develop within your departments or the develop group and also develop disciplines. So there's of course it requires maybe some additional incentives, but it could be very useful. So there are already resources build up, knowledge, and problems are there also, right? So you can actually also country can become can be very interesting in terms of, like I said, sediment is also a resource in Nepal. I see huge possibilities even to utilize sediment as a resource.
Hi, Dr. Sanjay Dai.
Hello, Kesa. How are you?
I'm good. I have one question regarding like uncertainties in flood modeling. So as you know that already.
Yeah.
So like especially in the context of Nepal, so we have like huge challenge with sediment transport and others, and especially the rivers. When you go from upstream to downstream, they are from single channel to braided. So since we do not have like very good data set in especially in terms of terrain, so like is using satellite imagery like enough to do morphological modeling, or we need to have some kind of like UAV lidar system or airborne lidar system so that it can capture land at an accurate terrain. So like I got this I wanted to ask this question because I was comparing a latest satellite imagery, most advanced satellite imagery, satellite terrain with my like UAV lidar, and I could see there are uncertainties of like plus minus 3 meters in that. So like how like these terrain can have impact on flood modeling practices, and since like morphological modeling they need like meso scale features, micro scale features like ripple dunes and anti dunes. So like I have like just have a question in
Yeah,
that.
I understand. So I understand your questions. Yeah, it depends. You see what kind of rivers, what process you want to capture. Yeah. So if like when you're talking about Brahmaputra, which is like 12 kilometers even in upstream wide,
Mm.
and changes like kilometers and hundreds of meters and kilometers, then and to measure it with even drone or something is not easy. Yeah. So very small area you can only capture. So that's why, but to capture using satellite images actually possible. So, uh, and with a little effort, less effort, and also financial resources. Um, so it all depends. And you're talking about microscale. Like in Netherlands, they also consider microscale because laterally their rivers are stable. So there's no lateral dynamics. And of course, they look at the flood impacts on like 5 centimeters, 10 centimeters even, right? So if there is a, microscale features will have like, if you change 5 centimeters, then this project's cost will go up millions. Yes? But of course, it is also possible to maybe somehow, at least in terms of decision making, to come up with this kind of numbers. So, and technologies are there. And this all about as I said, where you want to do it. In United States, a small river, streams, with a settlement around, so that you can also measure nicely using all those remote sensing techniques, and then you do studies, and that's what actually they do. Or in the Netherlands, the Rhine River, they measure every year or even 2-3 times a year. because there is a system in place. There are resources, both financial and human resources are there. So you can do that. So, and importance and accuracy is also like depends. Like sometimes for decision making, maybe you don't need to accurate. So you need some kind of like criteria that will make the decision makers easier to do certain decisions. So it's not always about accurately modeling things like in that you do in your PhD or master thesis. When you talk about your PhD, yes, of course, then you have to indeed try to find out as accurate as possible. The measurement, use as advanced as possible the techniques, because you are doing PhD, right? So you have to be also innovative, and your purpose is also like to which level, to which precision you want to, and then what kind of uncertainties you want to analyze or see, and what is the research and practical value of those uncertainties. But you are right that there are like 5 meters. Yeah, you might get 5 meters of inaccuracies, but sometimes even that would be good enough. Like in Brahmaputra, if you get 5 meters of difference, I mean, in certain data, it may not have much impact on certain process that you want to predict or replicate. So it all depends on the area and then purpose, those things.
Thank you, sir.
I saw one
So
question
because
here
of
from Thakur Sharmaji. Just quickly,
yeah,
I think I answered this question partly. What suggestions would you give to municipalities who are hell-bent to mine the rivers without having knowledge of river morphology and its behavior? Yeah, I already, I think, suggested in one of my previous that you have to indeed understand the river properly, and which starts with indeed collecting data of those rivers who are, I mean, responsible for like giving, giving permission or to these activities. So it's their responsibility to indeed collect the data and then do some proper analysis of their impact and effectiveness.
So there is
Thanks.
one more question about the river bank erosion model. So is there any specific erosion model for which can be utilized for modeling river bank erosions? Or
yeah, there are models, yes, but it's not easy. Yeah? So it's there are actually, I showed you the mentoring, the fundamental research mentoring. So it actually it has a bank erosion model. It's like the a mechanistic model developed by Professor Parker, which considers the slump block failures, mechanistic failure of the banks, and also the accretion of the inner bend. There are also certain parameterized, way of considering the bank erosion. For the large scale, it's quite challenging because, it's very difficult. If you want to have the model, then you must have also the information about the banks, what kind of material, and what is the properties of the material, and all these relations that calculates the erosion, includes all kind of bank material properties, coefficients, parameters. If you change a little bit those parameters, you get like very different numbers of bank erosion. So there are, of course, formulas, approach, and models, but they all have very high uncertainties. So you have to be very careful when you use them. So you also should understand the process yourself, and that can be very different in different rivers. In some rivers, like with the clay bank or Brahmaputra River with the very fragile, there can be very different bank erosion processes. So, but to predict is very challenging. Yeah, maximum we try to do it for 1 year, one flood season, but giving numbers is very difficult. We can say, okay, this bank is vulnerable. It will be maybe eroded, but how much it will be eroded is not easy. So there are models, but it's not about maybe models. It's also about knowledge. So you should understand like the processes of the bank erosion, and then try to see first the vulnerability of the bank. That is, I think, more important. There is
so
one more
there is
question from Rocky.
one
In the
question
fluvial science community, it seems that sediment transfer from watershed and its routing are not thoroughly studied, fully integrated with the river dynamics. But also actually watershed erosion or what catchment erosion may not also be always important. Like for example, in Brahmaputra, the most of the transport and morphology is because of the changes, because of the land erosion, the erosion of the fluvial land, the river itself. There is, of course, transport from the catchment, definitely. So through the landslides and all those, and in the pulses. So it's also, we have to very carefully look actually whether the catchment erosion or surface erosion is really a problem. I mean, or really the source of the sediment, like in certain rivers. And what kind of process, like in our hilly rivers, we have a lot of landslides, and they are through the tributaries, they may be transported towards the rivers, but in what was the process of those transport? So like in the pulses, so the deposited materials, they only transported maybe during only certain floods, right?
Mhm.
And of course, there is certain catchments, like in South India, you have a slope erosion or catchment is very important. So all those materials in your river is like 80-90% coming from catchment. Of course, everything is from catchment, but every flood, like in every flood, I mean, right? So which erosion process is important? So of course, sometimes we indeed do not consider, but sometimes also we are too much always towards, like, if you do some, if you plant some forest, doesn't mean that you get rid of the sediment transfer morphology in the river. Because first we have to indeed understand the whole like sequence of the processes. What are the real like sediment resources? What kind of catchment processes? So slope erosion, sheet erosion, gully erosion, or landslides, and then river erosion itself or river bank erosion. Like Brahmaputra, most of the, sediments, huge amount of sediments coming from banks. You can imagine, right? So if you have 1 kilometer of erosion, how much sediment is generated there? So it's important to, it's very typical for each, river systems. So we have to, that's why this is very, river science is interesting because every river is different. And this, morphology, this very, why it's interesting because every river is different and every system has its own, and there's also different processes, very different process. The process could be very different. So that's why it's quite interesting. There's a lot of questions, unfortunately, maybe we cannot answer all, but you can send email or it's night
Yes,
now, right? In
yeah,
Nepal.
we can arrange that we can all the unanswered questions we can definitely answer it later through email. So we can do that. And finally, I would like to request Sarosh sir to if he wants to add something to the discussion, like sub questions you want to answer or add to it.
Yeah, most of the questions has been, addressed by Sanjay sir. A few,
Yes.
like you mentioned that your PhD is also in the field of sand mining.
Yes,
and
sir.
sand mining is a very critical issue in the context of not only Nepal, but also India, particularly illegal sand mining, we say. And we are working towards, we are working with local governments, like how can we support them technically? I mean, to identify which place to mine and how much to mine. So and basically, while we think about advanced technology, I think there are some simple technologies or simple methods like we can start with to help to maintain the sand mining process sustainably. So that is what we are doing is we are trying to take the river cross sections for a few years and at different locations where generally the river is the aggregating rivers. Few years back, Sanjay sir and we together visited one of such rivers in Tarai plains of Nepal. So if we monitor the cross section for 2 or 3 years or 2 or 3 floods before and after flood, then we can know that how much the sediment is being deposited.
Yes.
If you take cross sections at 5 or 10 locations, then we know that okay, somewhere it is being eroded, somewhere it is being deposited.
So
So
we
if
can
we
have
take
the
average, then
understanding
we
of the
can say
stream
that
power.
yeah, Yeah, steam power. And what we can say is that, okay, the average sediment deposition, depth is this much. So let's start with this much depth of sediment we can mine, without any disturbing the river morphology. So that is what we are doing with the local government. So maybe in few years, that process can be integrated in the policy framework or something. And we are also, advocating that the sand mining should be mainstreamed, and it should be based on scientific evidence, not just based on the political opinion or the opinion of the administrators who are not technical people. So that is one of the main issue that I want to highlight. And the other thing is that in the context of Nepal, as I mentioned, river morphology is a very a challenging area of research. So, but if we can collaborate, all the interested people, like the expertise of Sandesh or other, then I think we can contribute in the long run.
Yes,
Yes,
definitely.
yes, yeah,
Thank you.
correct. Yeah, we tried a lot, of course. Yeah, we have been trying, and every flood in Nepal has a morphological, signature. So all the floods we analyze caused by. And now I saw some questions about this bridge impact on Sunsari Morang, irrigation. We had done analysis, and one of the students from irrigation department did the thesis with me, how this execution of this bridge cover dams impacted this morphology in that part of and then eventually that the Sunsari Morang intake affected. And it's good that like people like Dr. Saroj and they are trying to, in fact, indeed to influence so the local authorities that it is required, and it's not a bad thing mining, and they can actually do so. You have to go from that perspective. You can even earn more if you do it in a proper way, and it requires maybe a bit more studies. So like I did a lot of projects in the Netherlands in the past when I started my career on impact of mining or impact of any infrastructure building of a platform for bridge construction, and then impact of that platform on river dynamics and morphology. So these are like this in these countries, they are investing not because they are rich, because they are poor. They are poorer than they cannot afford investing on certain without knowing the impact and future, like effectivity. This we are rich, that we are investing everywhere without any studies and throwing money, like here they will not throw even 1 crore without any proper analysis and justification. So it's not about being, and that's why maybe they become rich. Sometimes people argue that you are in a rich country there. That's why it's not about it. They don't spend a penny if they don't see the return. So it's very actually in Nepal. Actually, we should do something. I'm always ready to do anything. You guys are there, so I tried few things, and well, let's see. I still have some time. Hopefully, we can do together all in our subcontinent in India. Now I'm working. Actually, it's quite interesting. In India, I find good actually. They now started to. In every project, there is a position for morphologists. The problem in Nepal is I see the projects that there is no position for morphologists, as if. But in India, I am very fascinating. Actually, they have in one project like position for morphologists and sediment transport experts, erosion experts. 3, 4. In one inland water projects, they have 3 morphologists position with a PhD degree. So, and every project has this position now in India, in every river projects. And in Nepal, unfortunately, I don't see even very important, rivers studies. There is no, even morphological studies, they don't have position for a dedicated like morphological experts. And then that's why also, it doesn't, so I am inspired like work in India because I see that, there's, I have a value, right? So, and they understand that it is an important topic and they need a dedicated line experts. Correct? So these things actually should come with with time and hopefully with the help of people who are now in the helm.
So let's hope, sir, that under your guidance, some of the young fellows like us, we can, drive these changes in Nepal, and maybe in like just coming future, we can, make this awareness, or we can make the government bodies, the people, everyone aware about the critical challenges that morphology poses, and hopefully the coming generations, they will be more careful about these matters. So
yeah, it's
I
changing.
think
It's nice. Yeah. When I started, we didn't have in Nepal. I didn't see like. I thought Umesh Lochan were our taught the first morphologists, but then now I see also many of you studying river dynamics, mining, morphology in different universities around the world. This means already that you are aware of it, and the community is growing. And also it becomes interdisciplinary. So our even ecologists or fish experts, they become interested in. So I do a lot of multidisciplinary projects, so I have to deal with different experts. So, and it's very interesting when we see how our works are interrelated. So I think it's good. I'm always ready here for any. Of course, I'm a little bit busy, unfortunately, with work and so on. Also, but anytime you need some kind of dedicated presentations or help, Raviji, if you need any help with your research,
definitely.
your work, even in Nepal, I do a lot of voluntarily. Also, I work. I can contribute voluntarily in Nepal, even in India sometimes.
Yes.
When I have time. Maybe I will have more time. Let's see if now I'm getting older. Yeah, so reaching. So I will try to find some more time, less work, and do more volunteer work. Maybe also in Nepal.
Thank you, sir. Thank you so much, sir. So
and thanks
I think
again.
we are
It's a
at
night
the end.
in Nepal.
Yeah,
It's great.
yeah,
Some
yes.
people still maybe awake
Yeah.
listening to this boring stuff, but
so
thank you
now we
for.
are nearing the end of the webinar. So let me just summarize the webinar, this session in just 2 lines, if I may. So we explored the critical role of river dynamics and morphology in effective river management with practical insights from our speaker, Sanjay sir, and and the diverse perspectives from our panelists, right, from Nepal and from the global perspective as well, by Dr. Ganesh. Uh, so now I like to extend my deepest gratitude to Dr. Sanjay Giri, Dr. Sarosh Karki, and Dr. Ganesh Khimire, and Dr. Santosh Kaini for their contributions. And a special thanks to the organizing committee and all the participants who beared with us and who are still there listening to us for making this event a success. For those interested in future engagement, please visit the website of IIHR, and we will be reaching out to the all the people through email. So you can also put your remaining question over there, and we'll try to collect it from our panelists as well as our speaker, and then we'll try to reach you back. Now I'd like to hand over to the CEO of IIHR, Mr. Rakesh Kumar Chaudhary, for the vote of thanks. So
Thank you,
Rakesh
Ravi.
sir.
Good morning, good evening, everyone. I am truly honored to have the opportunity to propose vote of thanks for today's webinar. Thank you all for being here. First and foremost, I would like to extend my heartfelt gratitude to distinguished speaker Dr. Sanjay Giri for his immensely insightful talk on essence of river dynamics and morphology in river management principles and practices. I hope today's discussion have been very much effective for researchers and practitioners both. I would like to extend sincere thanks to distinguished panel member Dr. Saroj Karki and Dr. Ganesh Gimbre for their insightful, engaging discussion. Now I would like to extend thanks to all the collaborating partners and organizations, and especially Dr. Santosh Kani for from Department of Water Resources and Irrigation for his support. I would like to thanks all the participants for their active involvement. Now, last but not least, I would like to extend the thanks to all the organizing team members for their dedicated supports behind the scenes. Uh, thank you all. Now, I would like to end the sessions, and I hope we will organize these kinds of webinar in the futures. Thank you all. Have a great day.
Thanks, Rakesh bhai.
Thank
Good
you.
luck,
Thank you,
Ravi ji.
everyone.
Please keep in touch,
Okay.
Ravi ji.
Right,
Yeah,
Your
definitely, sir.
research is very interesting,
Yeah.
and you are
Thank
in
you. Thank
Dhanbad.
Yes.
Okay.
Yeah.
So let's
Definitely.
try to find some way of also collaborating.